Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
As usual, I'm teacher Patrick, and I'll be taking you through chemistry for senior 2. But even senior 1 and senior 3 can still follow the lesson because it is very necessary. So if you remember very well, in the previous lesson, we were talking about, if you remember very well, we are talking about the categories of chemical reactions and categories of chemical reactions. And we looked at a number of reactions. For those ones who probably missed the lesson, I'll just briefly take you through about what we looked at in the previous lesson of Senior 2, about the categories of those reactions. If you remember very well, we talked about a number of reactions that we even did some of the experiments to verify those chemical reactions. One of the reactions that we looked at was combustion. We looked at synthesis, combustion, to be precise, or maybe to go back briefly, we said combustion is similar to burning. When a compound combines with oxygen, and we call that one combustion. I remember giving you an example of the respiration that takes place within our bodies. It is similar to combustion or burning, because the food combines with oxygen to liberate the energy. So that is one type of the reaction that exists actually in nature. So we talked about the synthesis reaction, where we said in the synthesis reaction, or even commonly known as combination reaction, we said in this reaction you have two elements combining together to form one substance or one compound. Giving an example of here, we said if you have hydrogen and you react it with oxygen, this also is similar to, this can also be a combination reaction. Because we are having water. Water is made up of hydrogen, 2 atoms of hydrogen, and 1 atom of oxygen. So this gives us the water molecule. This is one substance formed from its elements. That is a synthesis reaction or a combination reaction. We mentioned a number of reactions and gave even some examples. Another reaction that we talked about was about the replacement. And about the replacement, we said there are two forms of replacement. If you remember, we talked about, we said there is a single replacement, and then there is double replacement. Those are both of them. This double replacement, we can also call it replacement or displacement. Those words are used interchangeably, and they mean the same. So displacement, we said single replacement, double replacement, or sometimes it is called double decomposition. This is similar to even precipitation. Now, if I take you, probably giving some few examples, I'll not look at very many of them. I'm just helping those ones who could have missed this, so that we probably now continue, go ahead together. So in the single replacement, if I give an example of the zinc combining with dilute sulfuric acid, we said we are forming a salt of the zinc plus the hydrogen gas. This gas that is displaced, so it means when you look at this salt, the hydrogen, this hydrogen is displaced or replaced by the zinc metal. So we said this is one type of a single replacement reaction. Or probably if you have zinc, and I remember we did this experiment together for those who were around that time. So we said this zinc can displace the copper from its solution to form zinc sulfate and the copper metal. So this copper is displaced by zinc, and this is a single replacement. That is one of the reactions that we did the experiment, where we had to put the zinc metal or the zinc strip into the copper 2 solution, and then the zinc, the copper metal, the brown particles of the copper were formed into the solution in the previous lesson. And if I also emphasize on this reaction, I said this only happens, if you remember, I said if you have copper and then you add zinc sulfate. If you remember very well, I said this reaction cannot take place. This one doesn't take place. And I said why? Because this reaction, copper is less reactive, so it cannot displace the zinc from its solution. We are using the reactivity series, if you can remember. Do you remember the reactivity series? I hope you are still remembering, and I believe you put it down. You have to memorize that one because you can use it in a number of reactions to help you to tell whether this reaction will occur or not. So that is the reaction. So we are talking about the double displacement or double decomposition. We said you have two solutions. An example of lead nitrate solution combining with maybe dilute sulfuric acid. This is another solution, double displacement. So the zinc, the lead, one cation of one solution combines with the anion of another solution in this form. So the hydrogen with the nitrate, this will form nitric acid. Nitric acid. Then this lead will combine with the sulfate, and then it forms lead sulfate. This is double decomposition. I said it is the same as precipitation. The precipitation, because this is formed as a solid, that is why it is called precipitation reaction. So today, we are just going to look at we are going to look at decomposition reaction. Decomposition reactions. And we'll use a number of, we are just going to see this one. We are just going to do some demonstrations that will help you to probably memorize or remember what we mean by the demonstration. We are just starting with this lead. This is lead nitrate solution. And I'm just going to add a very little of it into a test tube. And then we'll have to heat. We have a source of heat here. So you have to take a look at what is happening. Maybe it may take some few minutes, but you have to be patient. So don't just put it there and immediately then run away and then say, no, this one has not worked. So you need to be patient. And I believe you have started hearing some noise. There is some noise coming. And if you look at here we have their crystals, white crystals. I believe you can see what is the color is trying to change. So one of the characteristics that will tell you that decomposition is taking place is the change of the color of the substance. That is one characteristic that you can use. And another one may be a gas can be liberated. And then this is what we are going to see. The gas is either the gas can be colorless or the gas can be colored or having the color. In this case, we are going to see what is happening. But The characteristic that I was talking about is the change of the color of the substance. So you can tell the color is changing. So that sound is called crackling sound. And you can easily see that the gas is coming out. The gas is coming out. That gas, it is that escape of the gas indicates that there is decomposition is taking place. One substance decomposes into a number of products, more than one product that is forming. So lead nitrate crackles. As it is crackling, then it is changing into other substances. So what we are interested in is to see that is the decomposition taking place, and what tells us that the decomposition has taken place. And I said one of the characteristics is the production of the gas. This is nitrogen dioxide gas that is coming out. Nitrates decompose to produce nitrogen dioxide gas, except those ones of group 1, as you could have studied even in senior 1. So that is reddish-brown gas, which is nitrogen dioxide. So this gas, we are not going to produce a lot of this because it is also poisonous, but that is one of the examples that can tell that the decomposition has taken place. So what is happening? So you have lead nitrate. You have lead nitrate. Lead nitrate. It is in solid form. Then it decomposes into lead oxide plus nitrogen dioxide gas. This is the gas that was coming out. Very clearly, you can still see that reddish-brown gas is nitrogen dioxide, then plus the oxygen gas. You will not be able to see the oxygen gas in here because oxygen is colorless gas, but there are two gases that are being produced. So the residue that remains behind is that substance, the solid that remains behind. It turns yellow. You see, it is turning yellow on cooling. That is yellow. But it was red. If you see inside, it was reddish-brown. So this is reddish-brown. Reddish-brown when it is hot, and then changes to yellow when it cools down. Very interesting substance that is happening. So that is one of the examples. One substance giving a number of products. That is also a decomposition reaction. We are going to use even some other substances. It is not only that one, so we look at other examples. This is zinc carbonate. So we're looking at the nitrates. So we are using the carbonates and the nitrates because there are some substances, not all substances decompose. There are some substances that cannot decompose on heat. So that is why we are using some of the examples that decompose on heat. So we are using, that was zinc carbonate, and then we are going to decompose and then see what is happening. So as I said earlier, patience is very important when you are doing the experiment. Patience is very important, I repeat. So probably here, because the gas probably that will come out may not be as colored, so we will not be able, maybe we can test the gas, because the other one was very clear, it was colored. But the gas that comes out here may not be colored, but then again, there could be even also a change in color of the substance. Just take a look at the substance. You see it is turning yellow, slowly turning yellow. I think you are seeing the yellow color is coming. So this is purplish blue litmus paper. So you commonly call it a blue litmus paper, but when you look at it, it is purplish blue. There is a purple color in it. So it is turning yellow. And when you look at the litmus paper, this gas that is coming out, this gas that is coming out, you see it is turning it pink. It is turning it to pink. So that means this must be an acidic gas. Must be an acidic gas. Blue litmus paper turns red or pink. That indicates or that shows the acidity of the gas. Turns yellow. The gas that comes out cannot be seen. It is a colorless gas. It is turning yellow. And the litmus paper turns pink. And what does that mean? That there must be a gas that is turning this litmus paper bluish purple into pink. That is why we can tell. That is one of the characteristics. I said production of the gas or change in color, yellow, from white. So the zinc carbonate is changing into the zinc oxide plus the carbon dioxide gas. So this is the substance. When you look at this substance, the yellow color will disappear slowly. Just have a look at it. It is not the same way it was even before. You'll see the yellow color is disappearing slowly, and it is turning again to white. So if it turns again to white, that is a distinct characteristic of zinc oxide. That color is only distinct to zinc oxide. Like the color of the lead 2 oxide, this zinc oxide is also has its own distinct color. So it is, this is yellow when hot, and white cold. Changes to white again when it is cold. Let's also look at the lead carbonate. We have a number of them, so we're giving examples of the decomposition reactions. And then we see what happens with the lead carbonate. At least you'll be able to remember in one of the examples. If you are asked to name the examples of the decomposition reactions, then we have made a lot of, we have a number of them. At least you'll have to remember one. So this is, we are now dealing with lead carbonate. So just take a look at it also, keenly please, and patiently to see what is going to happen. So lead carbonate, like zinc carbonate, also decomposes to give carbon dioxide gas. And carbon dioxide gas also, as we have seen in zinc carbonate, turns the litmus paper, the bluish purple litmus paper to red or pink. If you see very closely, you see the color changing there, coming to brown. See what is happening there? It is coming to brown. I think you can see the brown color there coming. That's a brown color. There must be a gas coming out, because zinc lead carbonate behaves in the same way as, I think you can see the color that is changing. It is changing to brown. Maybe you can heat a bit and be patient and heat and see what is happening. So when you heat it strongly for maybe more than 5 minutes and you don't see any change in color, it means the decomposition has completed. So that indicates the end of the reaction. So it is changing to brown. This was lead carbonate, remember? So lead carbonate, now this one forms lead oxide plus the carbon dioxide. Reddish brown, which is there. So we have to wait and see. Maybe we'll come back to it again and see what is happening to the lead oxide. If you look at it very closely, down here, you see it is turning into somehow yellowish. Yellowish. It is turning yellowish. So that means reddish brown, as we had seen before, turns to yellow on cooling. Just have a look at this. It is turning to yellow. So after some time, completely turns to yellow. Like zinc here, when you look at the zinc, this was yellow when it was hot, and then it is white again. So those are the unique characteristics of these oxides. And then we have another one. This one is very interesting. This is ammonium carbonate. Ammonium carbonate. So we'll have ammonium carbonate also decomposes. Can you suggest and write the equation there? I hope if you have your notebook with you and write the equation that will take place. So you have the ammonium carbonate, and then we have to heat it as well. Interestingly, this one, we are just going to use a red litmus paper. This is red litmus paper. We call it red, but it is pink. So we are just going to heat. Just put it in there. And then patiently heat the litmus paper. See the changes that are taking place on the litmus paper. It is turning to blue. And then continue heating. So what does that mean? That there must be an alkaline gas. There must be a basic gas. So ammonium carbonate decomposes to give two gases. Let us wait and see what is happening. So the red litmus paper turned to blue. So if it turns to blue, that is an indication of the gas that is coming out, which is alkaline. That is an alkaline gas that is forming. That alkaline gas must be ammonia gas. There is no any other gas that we look at that turns the blue litmus paper, no, the red litmus paper to red. Patience is very important as you are heating these substances. So when it is changing, if you can just take a close look, maybe it is getting over, but it is what we want is coming. You see it is turning again to somehow purple again, or somehow pink again. If it is turning to somehow pink again, what does that mean? It means that there is some other gas which turns it to pink. So it starts from red to purple, or rather from red to to blue, and then it is turning again to purple once again. So there is purplish pink color that is coming. So the pink color, when you look at it very closely, the pink color was coming. Fortunately, the gas is over, but there is some pink color that is coming over there. And what does that mean? It means that this ammonium carbonate is the one that was decomposing, and this one is producing the ammonia gas. This ammonia gas is the one that turns the pink litmus paper to blue, and then you have the carbon dioxide, which comes last. So the carbon dioxide is acidic, so the blue litmus paper, this one turns blue, red to pink, and then the pink again, that is the same litmus paper, turns to this was red to blue, sorry. Red to blue, and then blue to pink again. So the pink and red are used interchangeably, so you can use either pink or you can use red. The pink and red depends on the concentration of the gas or even the nature of the gas. There are some gases which are strongly acidic and those ones which are weakly acidic. So the strongly acidic gases will change it to completely red. If it is a very strong acid, then it turns it to red. But if it is a weak acid, then it will turn it to pink, which is closer to red. So that is basically what we were supposed to look at in decomposition reactions. So these are some of the examples that we have looked at, but these are not the only examples. So you can even look at some other examples of these reactions, or look for other examples that also undergo decomposition reaction. So before I wind up, I just want to give you an exercise. No, it's a homework this time that you'll have to work out, because at least we have covered a number of reactions, and this one will be including all categories of the reactions that we have looked at so far. So for each reaction indicated below, show the type of reaction occurring. A, so you have to write the type of reaction there. B, so you have chlorine and hydrogen. C, you have magnesium carbonate giving magnesium oxide and carbon dioxide. So we'll see have iron metal reacting with the hydrochloric acid, form iron 2 chloride and hydrogen. And D, you have methane gas combining with oxygen gas to give carbon dioxide and water. Indicate the type of the reaction over there. And A, you have magnesium plus zinc chloride. This will give magnesium chloride plus zinc. So indicate the type of reaction, and that is the end of the homework. I thank you so much for listening and watching. We'll be together in the next lesson. Thank you. See you again.